I'm in Garvin County, Oklahoma at the Murray 14-2 site, which is in the middle of the 5-mile area we're currently shooting our 3D seismic on. This is Triple Diamond's first seismic, and we're really excited to get the results back, as they will enable us to pinpoint our drilling locations with much greater accuracy. Obviously this is an expensive test, but I am confident that the benefits we reap from this seismic will not only justify the costs, but encourage us to do additional seismic in the future. The main advantage of seismic is that it provides the most accurate rendition of the geometry of subsurface layers. The objective is to determine the lithology and geometry of these layers. A seismic wave can be thought of as a shock wave or vibration traveling through the ground. The rate of travel or velocity of the wave is related to the density of the rock. Here's how it works. The procedure used is to lay out a survey line with these geophones set at equal spacing along a line. In this case, we have the geophones set at every 660 feet throughout the entire 5-mile square radius. A shockwave is produced at one of the stations by dropping a heavy weight or detonating an explosion at a shot point. The shot point is the point on the surface directly above the zone of interest. In this case, we use these trucks. The 2 hydraulic arms lower the vibration pad, touching the ground, creating vibrations that go down to the zone of interest. We're about a quarter mile west of the Murray 13-2 in the 3D seismic area. As I stand here, I can feel the vibration from these trucks on the ground. Seismic timer is used to measure the travel time of the wave from the instant it is generated until the time the wave reflection is detected back at the surface. Times are measured for each of the successful stations along the line. Either semi-graphical or computer methods are used to determine the velocities. The reflections are plotted on a profile called a seismic section, which shows depths to the features of interest. Depths up to 20,000 feet can be measured routinely with an accuracy level of 10 to 20 feet. We will then analyze these profiles to determine subsurface folds and faults and help us target where to drill our new locations. We have approximately 24 hours left of actual shoot time, which could take anywhere from 2 to 7 days to complete, depending upon weather. It will then take 7 to 10 days to process the data, and then 10 to 14 days to interpret the data, at which point I will update you with the results and put forth our schedule for the final wells of our drilling program.